Okay, so start with question 1. The plane has Cartesian equation. So you are given a plane x plus 2y plus 3z equals to 6. So when you're having a plane equation, before we do any calculation for the questions, so from here you need to know that from the equation we can take out normal. Alright, so that is the information, hidden information under the Cartesian equation of the plane. So what's your normal here? It will be the coefficient of your x, y, and z, which is 1, 2, 3. So means that this plane having the normal in the vector of 1, 2, 3, 1i, 2j, 3k. So whether we use the normal or not, later we see the question. The first one question, find the acute angle between the plane and plane z. So another plane, when z equals to 0, what is the normal? We don't have x, we don't have y, so means 0, 0, and 1 z. So from plane equation, take out normal vector. Then to calculate the first question, angle between two planes. Angle between two planes, formula n1 dot n2 over modulus of n1 modulus of n2. So just now what we do with the normal, we can substitute here. Your n1, 1, 2, 3, n2, 0, 0, 1, magnitude, square root of x square, y square, z square. So this one leaving x square. Then what is your dot product? We get 1. Magnitude, 1 times 3, we get 3. Dot product, x times with x, 0. Y times with y, 0. Z times with z, we get 3. So magnitude, we get 14. So to get data, shift your course to the right hand side. You get 36.7. So that angle will be your angle between two planes. No need to minus 180 or some more. Unless your angle is bigger than 180 and the question asks for acute, then we do for acute. If the question didn't request anything, the angle that you get from n1 dot n2 over magnitude n1 n2, this angle is exactly the angle between two planes. Okay, so for number 2, determine the point of intersection between plane and line. So first step, just remember, first step, finding our line in parametric form. So this is Cartesian form. So in parametric, this is Cartesian form, where Cartesian form means involving x, y, z. So parametric, move back. The denominator here is 1, denominator here is 1, denominator here is 1. So when you find back the parametric form, it will be x equals to 1t plus 1. Y equals to 1t plus 1. Z equals to 1t minus 1, so minus 1 plus t. First equation, line in parametric. Second equation, plane. Plane pi. So plane pi in Cartesian, x plus 2y plus 3z equals to 6. Then what we need to do, we just substitute 1 into 2. Find back your t. Expand this. minus 3t. So how many t we have? How many t we have? 60. Then how many constant we have? 6. So t equals to 1. Then substitute t equals to 1 into equation 1. X will equals to 1 plus 1. Y equals to 1 plus 1. Z equals to negative 1 plus 1. So your value, x is 2, y is 2, z is 0. Put in point form in bracket 2, 2, 0. So this is your point of intersection. Go to number 3. State that whether position vector OP is it parallel with plane. So when one vector parallel with plane, indirectly what they want to tell you. Come with the plane first. The plane given here, you given a plane formula, right? Plane pi. So which is this? Which is having your normal 1, 2, 3. So plane. When your vector OP parallel with the plane indirectly. In plane, the vector involving here is normal. Correct? For plane, vector involving in plane is normal. So that's why when we're having a plane equation, we always can come out with normal vector. So from plane equation, we come out normal vector, and then from the vector OP, we can see the situation OP and normal, they are perpendicular. So how you going to show this vector OP parallel with the plane? Indirectly, we do perpendicular concept for vector normal with OP. Okay? So show your OP and normal, they are perpendicular, then your plane, it can be parallel. So OP given here, 1 over 2i plus j plus 3 over 2k. So to show that normal and OP perpendicular, we're going dot product. So dot your OP vector with normal vector. So 1 over 2, 1, 3 over 2, dot with 1, 2, 3. You see whether this one can get perpendicular or not. Can get 0 or not. Can get 0 or not. 1 over 2 plus 2 plus 9 over 2 can get 0 or not. What's the value you can get here? 7. So not 0. Means that, are they perpendicular? Are they perpendicular to here? So they are not perpendicular with the normal. Indirectly, is it this POP parallel with this plane? They are not parallel. Alright? So with the result here, we conclude that OP is not perpendicular to normal. Therefore, vector OP is not parallel to the plane.